So I think at this point, kind of here's our, I guess, definition of good soil quality. You know, aeration, drainage, aggregation, it's easy to work. That tilth is that physical process. Lots of organic matter and lots of organisms is helpful to that. A couple comments on soil pH. So as you notice, we're going over quite a really fast overview here. Hopefully you will be doing some of the readings that you've been given so that you can get the more details, or maybe some of it's familiar to you. pH, which is acidity and alkalinity, you know, the scale goes from lemon juice, even or battery acid on the far left, all the way up to bleach on the far right. And you can see that crops have a fairly narrow range. Some of the horticultural crops can be take more acidic soils, but we're really looking probably at plants for production. So if you know your soil pH, you have some limitations on what crops you might be able to grow without changing it. One of the main reasons why pH affects how a plant can do there is what it does to nutrient availability and how the plant was adapted to take up its nutrients. And you can see at the two ends of this scale here, like 4.5, fairly acid for a soil on the left, up to 8.0 on the right, fairly alkaline. If we go down sort of in the middle, you can see iron. Okay, at low pHs in acid soils, iron's readily available, but as soon as you start getting up into that pH range that's a little bit higher, it becomes less and less available. Okay, and then if you look just above that, calcium has the opposite pattern. So this tells you a little bit about what nutrient problems you might have in different soils. You could, of course, have directly toxic effects where it's toxic to a plant or toxic to the microorganisms, but more it's these indirect effects from what nutrients it can take up and how the plant's adapted to take up nutrients. And then finally, we wanted to talk a little bit about the soil as an ecosystem. Obviously, there's a whole food chain in the soil with some organisms that produce, you know, they use sunlight and they use carbon dioxide and they produce organic material, and then other organisms that feed off of those and feed off of those and going up the food chain. And it's all very complex and really exciting. Probably two of the most important relationships to know about actually let's back up here and talk about this for a minute. Two important processes that happen in the soil is this. I talked about the constant turnstile and cycling of things through the soil. And if we look at the top here, we can think about an organism, and it's made up of proteins and has all sorts of elements and stuff and molecules in it. When they die or they excrete, have exudates, those wastes go out, and some of them are available as plant nutrients. Okay, so plants can take those up. Meanwhile, other organisms also take up any of those nutrients that are floating around in solution and say, yay, this is the food we need to build our proteins. That process of incorporating them into their bodies is called immobilization. Okay, so mineralization is kind of the opposite of immobilization. And when something's immobilized, it's stored in the organism and it's not available for the plant roots. So this is the cycling we're talking about, and nitrogen and sulfur are probably two of the nutrients that are most affected by this because they're not natively in most soil parent materials. They're not in the mineral structures and readily available. Okay, wanted to quickly talk about two symbioses, how some soil organisms really help our plant growth. And you may be familiar with some of these. Nitrogen fixation. A lot of people know that if you grow legumes, it can add nitrogen to your soil. And here's just a diagram of how a specific bacteria can infect the root and form these little nodules and actually take N2 gas from the air and convert it into nitrogen, which eventually becomes available in the soil solution in a form that the plants can take up, which is really pretty cool. And this is a way that I showed the picture of the white ones and the pink ones, kind of shows which if your nodules are actually functioning or not. Another type of relationship that's really beneficial, and we're learning more and more about this all the time, but many plants form relationships with specific fungal species where the fungi actually infect the roots, and they actually, in a good way, because they sort of join with the roots and they give the plant an extended root system. Meanwhile, the plant gives some of its carbon and energy to the fungus, so they both survive or do better. They both benefit. Of course, there's the famous earthworm, and you can look at those nice, dark, rich earthworm casts up there at the top of the photo, which are usually really nutrient-rich compared to the bulk soil around it. And let's see, I think we're getting short on our time here. I'm still okay? Okay. I have a number of more slides in this handout, which I don't think we'll really get to. We'll go through in sort of a cursory way. And they're all about how to increase organic matter, which I think is kind of the take-home message I would like you to have, is that adding organic matter is a good thing for your soil, and it's probably good to read up on it a little bit. But the other things besides organic matter is avoiding compaction, because you lose those large pore spaces that are so needed. And another one is to maintain the surface cover with vegetation. Like, don't have bare soil. That'd be the more direct way to say it. Avoid compaction, don't have bare soil, and increase your organic matter content. And this is, I think I'll let you guys read that on your own, and there'll be some food for thought. I want to kind of look at the sort of the main ways that we can add organic matter. This slide talks about we can plant a green manure, a crop that we don't harvest, we incorporate into the soil while it's still green. If we plant legumes and we harvest them off, it really doesn't give us much nitrogen compared to any other crop. But if we leave it still green, or if we grow grass and add that organic matter to the soil, it really helps improve the soil quality. We can haul in things like straw or wood chips or peat, whatever, and add organic matter that way. We can add manures, whether we buy it in bags in the store or we clean out the barn and spread it. We can add compost. We're at a large scale. There's manure spreaders out there. It always amazes some of my conventional ag students because they think if you were on a larger farm, you'd have to be going out there with a shovel and spreading your manure over your 100 acres or whatever, and they don't realize that there's equipment available. Here's a large, this is an on-farm composting operation. I'm pretty sure I took this picture in Wapato, Washington about 10 years ago. Okay. So another way of increasing your organic matter is like what you're doing in your regular production. Grow healthy plants. Do things so we have healthy plants, they'll have healthy roots, they'll grow big, they'll add lots of organic matter even after you harvest the part you want to take, what's left behind. Okay. Minimize your bare soil, and grasses and forage materials are great for building organic matter because they can be very root intensive. Perennial plants that are in there that have a real good root system established are great. And finally, the kind of third way of increasing organic matter is by minimizing the loss of it. And the two ways organic matter gets lost, well, the first way we probably think of is harvest. I have it second on the slide here, but we remove our crop because that's why we're growing it. So obviously we're going to remove it, but do we need to take all of it? Do we need to burn our residue? Do we want to take it off the field or leave it there? Those are some questions we can think about in our management. Tillage. The more we till, the more air, the more the aggregates breaking up, the faster organic matter decomposes. So those are two ways of minimizing the loss of organic matter. And maybe I should end right here. I do have one more great quote for you in a couple slides, but I'll let you look at that yourself. Oh, Cinda says I need to go ahead. Okay. There's some credits, and here we go. Soil is the ecstatic skin of the earth. And that is actually the title of a book by William Logan Bryant, which I did not realize until I saw the movie that Dirt, the movie, have any of you seen that? That was based, well, inspired by his book of that title. And he was actually in the movie at the beginning, and I thought that was kind of fun. So anyway, thank you, and hopefully if you have questions, we'll have some time to answer them.
Right now we haven't had any questions come in from the students, so if you have any questions, go ahead and type them in, and we will answer them at the end of Jessica's presentation. Thank you, Kathy, and we can move to the next slide.
Look back there. Click here. Okay.
Great, thank you. So that was a great overview of soils. I know it's a lot of information. It's one reason that we give you the slide handout so that you can go back and review what Kathy's provided. Again, this presentation will be posted on the course website so you can listen to it again, and there's supplemental readings and assignments also listed on the course website. So Jessica, thank you, and we'll let you go ahead and talk about crop production.
Great. Well, good evening, everybody. We can go ahead and move forward with the slide. And I just wanted to take this evening and talk about crop production, because it's a big wide world out there of what everybody's going to be growing or currently growing, and we really need to focus on bringing it back to our whole farm goals. Next slide, please. So do you remember those whole farm goals that we first started with? We really need to think about what kind of operation are you wanting to do? Is it organic, non-certified organic, sustainable, biodynamic, grass-fed, free-range? What is it that you want to do? Because your crop management strategies are going to directly relate back to that operation and that whole farm goal. So as we talk about this stuff tonight, kind of keep that in the forefront of your mind. Basically, managing crops really relies on this simultaneous technique of conservation and improvement of soil, efficiency of water use and protection of water quality, prevention of pests and disease and weeds, and then ultimately this production of the highest quality product that we can possibly create on our farm. So managing crops really starts at the very foundation of what Kathy was talking about, and that is soil. When I say, what are you growing? I mean, we are all soil farmers first and foremost. Whether you're growing vegetables, Christmas trees, veggies, maybe you're growing livestock for milk or wool or meat, whatever it is, you are actually a soil farmer. Then you're a plant farmer, then finally you're a livestock farmer, and then you're on repeat. But this cycle that we have to get into when we're talking about crop management or ultimately enterprise management is really starting at that foundation of soil. And if we can keep our healthy soils or build the health of our soil, then we can have an excellent high quality product in the end. And lastly, when we're talking about crop management, just as a reminder, keep your records and keep detailed records. I would recommend getting a journal and just jotting down tasks, the hours that it takes you, what your production is like, any successes and failures that you have. This is a really great way to have a detailed yearly recap of what's going on the farm, what you wanted to do different every year, and what you really liked and disliked. When we're talking about crop management, it's a lot to remember every year. So just do it. Don't ask questions. Just start now and keep your records.